Hello and welcome back to differential equations on this glorious, what's today, Tuesday afternoon. We are continuing our exploration of Laplace transforms, and today 4.3 translation and partial fractions, more of the same, right? So we know for partial fractions that we have, so for partial fractions, if we have a setup that was a over x minus some, let me just see. So say you had 3 over x plus 5. That was linear. If you had that as a factor, let's put this. So the partial fraction setup for this would be a over x plus b over x plus 5. So that was calc 2. If you had a repeated, let's go with the repeated, so 6x x minus 2 squared, the setup would be a over x plus b over x minus 2, and then plus c over x minus 2 squared. So that's that. And then we go with the quadratic ones. So you have an irreducible quadratic, right? In that case, you can, if you have irreducible quadratic, say whatever on top, I'll just put blah, divided by some kind of ax squared plus bx plus c. The setup is, and let's multiply that by x, right? Linear term. I'm just gonna make mess. The setup for this is ax plus b divided by ax squared plus bx plus c. Actually, I don't need these parentheses now that I'm not putting anything else. And we also have a repeated, so here's the blah on top, and I have ax squared plus bx plus c, everything squared. That's a repeated unfactorable. You would have ax plus b divided by ax squared plus bx plus c, and then plus cx plus d repeated, and then square. So this is the setup from calculus 2. But now we are going to sweeten this deal, because when you multiply, you can, in the exponent of e, it shifts the function in its Laplace domain. So we can think about the translation on the x-axis, and these are some of the main points for today. So if f of s is the Laplace transform of the f of t, exists for s larger than some value c, then Laplace transform of e to the at f of t exists for s larger than a plus c. I'll talk about this later. and here are the formulas. Laplace transform of e to the at times f of t is equal to f of s minus a, and the inverse Laplace of f of s minus a is equal to e to the at times f of t. What does this mean? Well, if you focus on this and this only, just focus on these two, you see that the Laplace transform of the function, it just gives you s, f of s, right? So you're changing the domain t into domain s. You're changing the function f into function capital F, in this case of s. So everything changes. Domain changes and the function changes. Laplace transform. But if you multiply the function in Laplace transform with e to the at, that a becomes the shift for the Laplace. Now, to see this in a proof is quite easy, because remember what you have. Laplace transform is e to the negative st, right? You has that. So when you have this one, you factor t and it becomes s minus a, right? So you have that as a shift. Now the bottom one obviously is the inverse Laplace transform, so just read it backwards, right? You apply inverse on both sides, it cancels on this side, it gives you that, and then you have inverse Laplace. So this is how we translate on the x-axis, meaning shift, move. So let's see. Now another point before we do examples. Another point is, so going back to these explanations, earlier I said blah over ax squared plus bx plus c for the partial fractions goes into ax plus b over ax squared plus bx plus c. This ax squared cannot be factored any further, but you can do completing the square on it. So you can complete the square and get some kind of a of, I don't know, x minus h squared plus k. And then what you can do is you can factor out a and get x minus h squared plus k over a when you factor out. So now it is k over a, you can call some new letter. And then eventually you can take a square root of it as well, and then you will have a completed square there. Now, I believe the textbook used s immediately in the s domain as a prep for inverse Laplace, because you're using partial fraction decomposition only in a situation when you are ready to go backwards to do the inverse Laplace. So the textbook gives this line as a1s plus b1 divided by s minus a squared plus b squared, and then plus a2s plus b2 divided by s minus a squared plus b squared, and then everything squared if it's a repeated, and that can go all the way to the end, whatever you need. So the partial fraction decomposition immediately gives you this s minus a here, and as long as you have s minus a, you know it's the e to the at in the inverse Laplace, because There you go, because red of there, right? So if you have s minus a, now s minus a could be s plus 3. A is negative 3 in that case, right? So that value for a could be anything. Doesn't have to be just a positive value for this to work. Now this section is clearly just really long and really painful, and I hope that you guys know how to use calculator to deal with the matrices in terms of solving the systems, because some of these problems will have 5 or 6 variables, which will create 5 by 5 or 6 by 6 matrices that you augment and then solve to find coefficients. So it's somewhat of a pain, but we have enough time to do one example. So we have 55 minutes and then another 2, which is 57, so we should be, maybe we can squeeze 2. Let's try squeeze 2. So do like a half example and then a full example. So use partial fraction to find inverse Laplace transform. Give me 11 through 22. 19. It's a good one. 19. All right, let's do it. So f of s is given as s squared minus 2s divided by s to the 4th plus 5s squared plus 4. So now, partial fraction decomposition, right? Well, first we have to factor everything that we can. So before I do this, I'm going to say s minus 2, because some stuff might cancel. And then denominator is going to be s squared plus 4 s squared plus 1. Is that bueno? Yep, that's it. Now observe that you have two factors that cannot be factored any further, right? They both have pluses. And because they both have pluses, we have to take care of them using the following setup. A s plus b divided by s squared plus 4 plus cs plus d divided by s squared plus 1. That needs to be equal to, well, this is s squared minus 2s. Since nothing cancels, I'm just going to multiply it back. S squared plus 4 and s squared plus 1. Now we actually taught this today in algebra. Play the game of what's missing, right? We go s squared plus 1 and s squared plus 1 and then s squared plus 4 and s squared plus 4. Alright, so now multiply everything through. As cubed plus bs squared plus as plus b plus cs cubed plus ds squared plus 4 cs plus 4d equals to s squared minus 2s. So get the cubes. Why did I write square? This is a cube. So a plus c s cubed plus So squares, I have b plus d times s plus, and the rest are constant terms. No, wait, that's s squared. I still have to do s. So a plus d. Oh, wait. And plus 4c, yes, thank you. Plus 4c plus d. And that's times s. And then plus, is that just b? 4d. There we go. Now we equal the coefficients. There's no cube on the right, so a plus c is 1. No, 0. And then b plus d is 1. And a plus 4c plus d is negative 2. And b plus 4d is 0 as well. Now, the way I'm going to solve this is I'm going to use the matrix on the TI-83 calculator. So to create the matrix, I get all the entries. So I have 1, 0, 1, 0, and the answer is 0. 0, 1, 0, 1, and the answer is 1. And then A is 0, no, A is 1, B is 0, C is 4, D is 1, and the answer is negative 2. And then the last one, 0, 1, 0, 4, 0. So I'm going to take this matrix. We call this augmented matrix because if I draw this line, the stuff on the right is the matrix, so it's a vector of answers. And now I'm going to use the calculator to plug this in the matrix and just solve everything at once rather than chase the equation. I mean, this system is easy to solve by hand as well, but so in order for you to use the matrix feature of the calculator, if you have these calculators with you, is you will push the matrix button, which is on x minus 1, all the way in the left corner, so yellow matrix, and then you will go to edit, and you will say that you are working on a matrix that is 4 by 5. So 4, enter, 5, enter, and then you will enter all of the values. 1, 0, 1, 0, 0, 0, 1, 0, 1, 1, 1, 0, 4, 1, negative 2, 0, 1, 0, 4, 0. So once you enter the matrix, all the rows and columns, you will hit second quit, so second mode, and you will invoke matrix again, but then you will say math. Right? You will have to edit first to put in the matrix, then say math. You scroll down to RREF, row reduced echelon form, push enter, then call matrix again, the first one, and there it is. And I don't like these answers, so we should I forgot how you turn this into a fraction. No, math 1. So the matrix of solutions is 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1, 5 over 9, 4 over 3, negative 5 over 9, and negative 1 over 3. So now that gives us 5 9ths s plus 4 thirds divided by s squared plus 4 plus, or actually I should put minus 5 over 9 s plus 1/3 divided by s squared plus 1. So just be careful that you're plugging in a and b exactly where they belong. So now that you have this, you split and you look at your chart. So what do I have? I have 5/9 times s over s squared plus 4 plus 4/3 times 1 over s squared plus 4 minus 5/9 times s over s squared plus 1, and then minus 1/3 of 1 over s squared plus 1. So every fraction, so this becomes 2 fractions, and this becomes 2 fractions over the addition in the numerator. And once I have split those, I put the fractions in front, right? 5, 9, 4/3, so I put them all in front. And now I have clearly sines and cosines, right? Do we all see that? So let's find a Laplace Laplace table, images, and anyone is technically fine. View image, and there it is. So now you see numbers 8 and 9. Numbers 8 and 9 are the ones that you want. So I think, let me just try this. All right, so five over 9, this is 2 squared, and this is 1 squared, right? So the one with s is the cosine, and the one with the number is the sine. So the one with s is a cosine. That's the cosine of 2t. Plus, now there's a little issue. This is 2 squared, and you are required to have a 2 on top then. Because if you go carefully look at your transform tables, the same b appears on top and bottom. So if this is 4, this better be 2 on top, right? So I have to steal 2 from the fraction in order for me to have this. So from this fraction, I have to steal 2 from 4 and leave it as 2/3. And then I have my 2 over this for sine of 2t. Minus 5 over 9, again cosine t, and over here is already 1, so minus 1/3 sine t. So it's usually is issue if you forget that it's the same b, that it's in denominator and the numerator. So 4 is 2 squared, and because it's 2 squared, this needs to be 2, so you're stealing 2 from here, so because 4 is 2 times 2, you move the 2 there, and then you have 2 over 2 squared is given this one, and you're left with 2 times 10. Right? Technically, cut in half. So that was just doing the inverse Laplace. Now let's do the entire problem. I will give you, some time to do the Laplace, and then we'll go. So, I don't know, any of these are good. How about problem 30, so we can all cry together? X double prime plus 4x prime plus 8x is equal to e to the negative t, and here are your conditions. X is 0, x prime of 0 is 0. There you go. Have fun for a few moments, and then I'll work on it. that enough time? So is this what you have so far? Okay, great. Now what do we do with the s squared minus plus 4s plus 8? Partial fraction quadratic thing because it's not factorable, right? Now, before I do the partial fraction quadratic thing, maybe, just maybe, let me see if I can get the easier answer if I do the completing the square rather than the partial fraction. Completing the square should be, right, easier procedure. So if I'm just going to, on the side real quick, go s squared plus 4s half of 4, so I need plus 4 plus 4. I break 8 into 4 plus 4 because I need 4. And then the first 3 will give me s plus 2 squared, and then I have plus 2 squared, right, which is 4. So it seems that this can break into this and give us easier answer. So I'll keep that in mind, that Actually, this is now in a way. So I'm going to write here blue. I'm just gonna say that this guy is s plus 2 squared plus 2 squared, which is 4. Alright, let's do partial fraction decomposition. What do I get? I have a over s plus 1 plus bs plus c over s squared plus 4s plus 8. That's the setup. And then I have, when I cross multiply now, I have as squared plus 4as plus 8a plus bs squared plus cs plus bs plus c, everything equal to 1. So I have a plus b equals 0, that's for s squared. Then 4a plus b plus c is equal to 0 again, and 8a plus c is equal to 1. So it's gonna be for me faster to do this by hand than to actually plug in the calculator. You can plug in a calculator. A plus b is 0, and I will subtract these two equations. So 8a minus 4a is 4a, 0 minus b is negative b, c minus c is 0, 1 minus 0 is 1. And now I will add these two equations to get 5a equals to 1. So a is 1/5. If a is 1/5, b immediately needs to be negative 1/5 because they have to add to 0. And then I figure out what c is. And c is going to be 1 minus 8a, which is 1/5. So that's negative 3/5. So c is negative 3/5. So the problem now looks like f of s is given as 1/5, let's say 1 over s plus 1 minus, no, we'll do plus and do negatives over here, negative 1/5 s minus 3/5 divided by s squared plus 4s plus 8. Now what I'm going to do is I'm going to factor out 1/5 in front of the entire problem. So f of s is equal to 1/5, and now I have 1 over s plus 1. I factor out 1/5, so that's a negative. So minus s over s squared plus 4s plus 8, and another minus for 3 over s squared plus 4s plus 8. Now we are going to replace each one of the denominators with their s minus 2 plus 2 squared, no, plus 2, and s plus 2 squared plus 2 squared. So those are denominators, and they're particularly good to be in that form because they give us this e to the at times cosine and times sine. But I need to fill those conditions. So the first thing that I need, well, let me let me write the formulas down. That way you will be able to see everything at once. Here in blue. So if you have s minus a divided by s minus a squared plus k squared, that would convert into cos e to the at cosine kt. And if you just have k divided by s minus a squared plus k squared, that converts into e to the at sine kt. So you already see that the k value is 2. You see that? Because when you complete the square, it looks exactly like this. It's in that format. So this and this, you see that your a is negative 2, and you see that your k is positive 2. So when you are figuring these things out at the beginning, that would not be a bad thing to write. So a is negative 2 and k is positive 2. So now you have to match this with what you have up there. Now clearly you have 3 over here on these. Over here you're going to have some extra stuff as well. So we have to figure out what to do with all of those. I need s minus a. Well, in this case, I need s plus 2, so I have to put s plus 2, s minus 2. Right, and then peel off that part. So there is some work to be done here to transform this. So I'm looking at the formulas, looking at what I have. The next step is to write f of s. F of s is equal to 1/5 1 over s plus 1. That's just e to the negative t. But the next one is I write s plus 2 minus 2. I need that. Divided by s plus 2 squared plus 2 squared. Minus the other one I need to write as 2 plus 1. Divided by s plus 2 squared plus 2 squared. So that I can use our formulas. This is equal to 1/5 1 over s plus 1. And now I have to peel off the negative 2. So it's going to be minus s plus 2 over s plus 2 squared plus 2 squared, and then plus 2 over s plus 2 squared plus 2 squared. And now I have minus 2 over s plus 2 squared plus 2 squared, and finally negative and positive make a negative. So minus 1 over s plus 2 squared plus 2 squared. Now I hope you see that these two guys, I wrote them one under the other, they add together, right? Actually, wait, no, these cancel. Do they? Yeah, these cancel, and what I'm going to do is multiply this one by 1/2 and by 2 to create the one for the sine. So you have to, you know, you gotta be creative with these things. So it turned out that these are the same, the ones that I was making for, so I need this piece for cosine, and I needed this piece for sine. But the piece for sine cancel. Luckily I have this one, which I can make into this one by multiplying by 2.5. So, and the final step here before we do inverse Laplace. I am writing f of s is equal to 1/5 bracket 1 over s plus 1 minus s plus 2 over s plus 2 squared plus 2 squared, and minus 1/2 2 over s plus 2 squared plus 2 squared. So we are going to hit this with the inverse Laplace now. The f of s goes back into, what was the original variable, x or y? X. So this goes into x of t is equal to 1/5, and now this is e to the negative t minus this one is the one that has, why did I write this? Oh, that's s plus 2. So it's going to be e to the negative 2t cosine 2t minus 1/2 e to the negative 2t sine 2t. And there it is. That's the answer. Everything is multiplied by 1/5 in front. You can distribute, you can leave it. You gotta chase these values around. See what's where. Feeling another one? Might as well. What else we're gonna do, right? Unless you want a new lecture. It's only 15 minutes. Let's do one more example. So you work for 5 and then I'll kick in. So work on this example for about 5 minutes and then I'll join you in your endeavor. Did you do any x cubes so far? Sorry, I mean the third derivative of. You didn't? Well, now you will. What happened?
I don't remember the formulas, like how the derivative for the
I think that's provided over here. Yeah. What happened? Yes. All right, so problem number 31. Third derivative of x plus second derivative of x minus 6x, and then x of 0 is the same as x prime of 0 is the same as x double prime of 0, which is equal to, I just didn't pay attention. This is equal to 0, and then conditions. All conditions are 1. So x of 0 is the same as x prime of 0 is the same as x double prime at 0, which is equal to 1. Right. Have fun. We might have different definition of fun, but have fun.
Do you not know X double prime?
That's X double prime, yeah. You have to print.
There's only X, X prime, and then X triple prime.
Yeah, it's supposed to be a double prime.
That's supposed to be in this one.
Yeah, can you erase it?
Gotcha.
There you go. Can you erase it?
I can't get it.
You what?
We'll see if I can get it.
Yeah, it has a eraser on the top. Yeah. Now it crashes.
Wait, is it on right now?
Yeah.
Hello and welcome to Differential Equations with Matt McClellan.
He was waiting for that the whole life. Why you erase one?
What?
Why you erase one?
Because I was gonna put it
That's
right
one.
there. I was gonna put it like X double prime right there and then say
you
equal
don't
to
need
1.
XL prime. You don't need XL. Just erase one of the tick marks.
Oh,
And
okay.
put the one back.
Damn it.
No, it's not easy, guys.
No.
XL prime and one over there.
And 1.
That's it.
The 1 is easy to do.
Yeah.
All right. Signing off.
Signing off. 50 seconds. Let's see if I can do this in 6 seconds or more. Oh, this is 1. Ugh. Why is it 1? Alright, so let's see. S cubed f of s minus s squared times 1 minus s times 1 minus 1 plus s squared f of s minus s minus 1 minus 6 f of s, at least equal to 0 on the other side, right? Less. So now I have f of s, which factors s cubed plus s squared minus 6 is equal to s squared plus 2s plus 2. I have to move this one, this one, this one, this one, and this one to the right side. So that's s squared, 2s, and 2. Awesome. So now I had that fs is equal to s squared plus 2s plus 2 divided by s cubed plus s squared minus 6. Is this what you guys have? Yes? No? Anyone? 17,000 people in a classroom and no confirmation. Yes. I am the legion. So, yeah, I think this should be good. This is the 3 terms, right? Y another minus 1. This one? Are you sure? Because just 6fs, no minus 1 there. Oh, that's a derivative. Yes, 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 minus 6. Minus 6 equals 0. You are right. So that makes this into 8. That's a derivative. So there is an s here then. It's going to be a 6s. So then this is a 6s. And now everything is confused. Alright, so let's count everything again. Yes, there is a minus 1, which means... No, I don't need... It's not 6, it's 1 just. Minus 1. Alright, so now let's check all of the things that we are shipping off. And that's gonna be a 3, right? On this side. Is that good? To be a 3 there?
Yep.
And then we have this one. So now we factor this as s plus 2, s plus 1. No. S plus 3, s minus 1. Would that work? No. So it doesn't factor. Great. And in the denominator we have s, and then I have plus 3, s plus 3, and s minus 2. Is that good? Hopefully. What just happened? Oh. So now, partial fraction decomposition, a over s plus b over s plus 3 plus c over s minus 2 is equal to s squared plus 2s plus 3 divided by s plus 3 s minus 2. Alright, so I have this one multiplied through, so that's gonna give me, so for the first one I'm missing s plus 3 and s minus 2. For the second one I'm missing s and s minus 2, and this one is s and s plus 3. So what do I have now? This is as squared plus as minus 6s plus, now that's bs squared minus 2bs, and then plus cs squared plus 3cs. So now I have a plus b plus c is equal to 1. A where is this term coming from? It's 6 as. It's 6a, right? It's 6a. So I have as 2bs minus 2bs and plus 3c is equal to 2, and negative 6a, that's it, just negative 6a is equal to 3. So from there I know that a is negative 1/2. So when I plug in negative 1/2 in a system, I get negative 1/2 plus b plus c equals to 1, and negative 1/2 minus 2b plus 3c equals to 2. There's no s there. I'm going to multiply both equations by, well, top one, multiply top one by 2, right? But then because of the fraction over here, multiply the bottom one by 2, multiply top one by 4. That will cancel the fractions and everything else, and then add equations. So I have negative 2 plus 4b plus 4c is equal to 4, and the bottom one is 2 times 1/2 is negative 1 minus 4b plus 6c is equal to 4. So now when I add equations, I get negative 3, this dies, plus 10c is equal to 8, 10c is equal to 5, c is 1/2. So c is 1/2, they cancel, so b is 1. Cool. So I have a is negative 1/2, 1 over s plus b, which is 1. So all I have is 1 over s plus 3. And then this is wrong. I was supposed to add this to 11, right? So 11 over 10, which changes the b. From scratch. So I have b plus 11 over 10 is equal to 3 halves. So times 5, that's 15 minus 11, 4 tenths, 2 fifths. Okay. I guess that's better. Negative 1 half 1 over s plus 2 over 5 of 1 over s something, s plus 3, plus 11 over 10, 1 over s minus 2. I hope you see that all of these are exponential ones. Except 1 over s. What's 1 over s? Is it 1 or t? Can be both. What? It's 1. So this is our fs. And if we apply the transform, that fs becomes f of t. If that is our, right? So it's negative 1 half plus 2 fifths e to the negative 3t plus 11 over 10 e to the 2t. I took 12 minutes of your life and no one complained. What? See? At least we got the problem done. Alright. So I believe we have 1 or 2 more lectures in chapter 4. We can talk about the exam. So let's talk about the exam next class on Thursday. Try to figure out what else we must do. Alright, bye stream.